Welcome to day 68 of our school year. All right. Let's get down our beginning fraction. We have a total of 180 school days. We are on day 68. Let's find the factors of our numerator, which is 68. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can also write 68 times 1. Now we're going to use our divisibility rules to find the rest of our factors. We're going to go in order though. So after 1 we try 2. The rule for 2 is that it ends in an even number. It does, so 2 is a factor. 2 times 34. 34 times 2. We're going to try 3. The rule for 3 is that we add the digits together. 6 plus 8 is 14. 14 is not a multiple of 3, so 3 is not a factor. We try 4. One thing to check for 4 is if the second factor with 2 is even. It is, so 4 is a factor. Okay. So 4 times 17. 17 times 4. We try 5. The rule for 5 is that it ends in a 0 or 5. It ends in an 8, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. 2 is, 3 is not, so 6 is not a factor. We try 7. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. Nope, 68 is not in that list, so 7 is not a factor. We try 8. 8, 16, 24, 32, 40, 48, 56, 64, 72. No, 68 is not in that list, so 8 is not a factor. We try 9. 9 has the same rule as 3. We add the digits together, get 14. 14 is not a multiple of 9, so 9 is not a factor. We try 10. The rule for 10 is that it ends in a 0. It ends in an 8, so 10 is not a factor. We try 11, 11, 22, 33, 44, 55, 66, 77. Nope, that doesn't work either. I'm thinking that this second factor with 4 may be prime, so let me check. Because if it is, and we've gone in order, then we're done, because it won't break down anymore. 17 is prime, so there's no more factors to find. Let's go ahead and list them from least to greatest. 1, 2, 4, 17, 34, 68. We have 6 factors. That is more than 2 factors, so it is composite. And let's go ahead and find our greatest common factor. So let's start with our greatest factor of 68. So remember, your groups, you have to keep the shaded separated from your unshaded, but they do not have to look like mine. They do have to have 68 though in them. So here I have 2 plus 60 is 62. I need 6 more to make 8. I have 44 left over. I do not have enough to make another group of 68, so 68 does not work. Let's try 34. So 30 and 4. 26 and 8. 32 and 2. 28 plus 6. And 4 plus 30. I have 10 left over, so 34 didn't work. Let's try 17. Make sure you keep your shaded separated from your unshaded. Make sure there's 17 in each group. So you want to use, you can count, you can also use decomposition. 2 plus 10 is 12, plus 5 is 17. 5 plus 10 is 15, plus 2 is 17. 8 plus 9 is 17. 11 plus 6 is 17. 4 plus 10 plus 3 is 17. 7 plus 10 is 17. And I still have 10 left over. So 17 is not a common factor. Does not work for 180. Let's try groups of 4. Use perfect squares to help me out a little bit here, but I have to be careful here because these shaded I have to keep separate from these unshaded here. So you just have to be careful with that. You do not have to use perfect squares. As long as there's 4 in each group. But this is why 4 is one of those numbers called a perfect square, because you can make a square with each side a length of 2 units. All right, 4 works. We finally found a greatest common factor. So let's count up our total groups of 4. Since each of my rows have 5 in it, I can count by 5s. 5, 10, 15, 20, 25, 26, 27, 28, 29, 30, 35, 40, 45. 45 groups of 4, and I have 5, 10, 15, 16, 17 shaded in. 17 times 4. All right, we've done our division with our model. Let's go ahead and divide using our algorithm. We always use the same numbers to divide by, and they have to be factors of both numbers. They have to be a common factor. So I know 4 quarters makes $1. So 4 times 25 is 100. Numbers the same, zero's the game. More on top, no need to stop. Numbers the same, zero's the game. Then I'm going to do 20 times 4. Placeholder moves it over a place. 2 times 4 is 8. Numbers the same, zero's the game. Add these partial quotients together. 5 plus 0 is 5. 2 plus 2 is 4. Here, 10 times 4 is 40. More on top, no need to stop. More on top, no need to stop. 5 times 4 is 20. More on top, no need to stop. Numbers the same, zero's the game. 2 times 4 is 8. Numbers the same, zero's the game. So you may have known that 7 times 4 is 28, and you could have gotten there faster. That's fine. But I just want you to see that even if you didn't know your 7s, use what you do know with your 5s and your 2s, and you can still get to the answer. 10 plus 5 is 15, 16, 17. We still need to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder is 0, though, and the identity property of addition says when you add 0 it stays the same, we don't need to actually add the 0. 4 groups of 5 is 20. 4 groups of 4 tens is 16 tens plus 2 more tens is 18 tens. 4 times 7 is 28, 2 tens and 8 ones. 4 times 10 is 4 tens plus 2 more tens is 6 tens. 68, that matches our dividend up here, so that checks. 180 matches our dividend up here, so that checks. That means our numerator is definitely 17 and our denominator is definitely 45. So let's go ahead and fill in our data collection page. Okay, trimester 2, week 2. Today is 11, 14, 19. And our fraction for today is 17 45ths. Okay, let's go ahead and get out our number line. We did groups of 4. So let's find our 4. The last group of 4 we have is 16 45ths and then 17 45ths. There's no lines below it because it is our simplest form. There is a line above it in the 2s, so there is an equivalent fraction in the 2s. 2 is a common factor, but 4 was our greatest common factor. All right, go ahead and put your number line away, erase your worksheet, and thank you for joining me.